talk to you about building evolutionary architectures, but I want to start with the question of why should you care? I used to get asked this a lot more than I get asked it now. In fact, when I first started talking about this, and I need to remember to ask Neil if this ever happened to him, people would come up after the talk and they'd come to the edge of the stage and whisper, "Don't you think you're being professionally irresponsible to talk about evolutionary architecture? Architecture is the rock, it's the foundation. You cannot evolve it, it cannot change." And it's like, excuse me? Have you seen what's happening in the ecosystem lately? Now, sure, there are probably some phases and certainly some organizations that don't have to worry about it because they can just throw everything out and start over. But that's not what it's like in most enterprises. And the truth is, we've actually gotten pretty good at requirements change. When customer expectations change, regulations change, our business model gets disrupted by somebody. But what happens when the ecosystem changes? And I don't want to take credit for this question because this is one Neil has done a lot. But he says, I will bet you 100 of whatever your currency is to tell me in a year what JavaScript framework you will be using. Well, you can't do it because it probably hasn't even been written yet. And so nobody's ever taken Neil up on this bet. But the fact is that when I started in this business, you really didn't have to worry that much about it because things changed very slowly. And so you could predict those things, and it was sensible to have a 5 and even a 10-year roadmap for technology. That is not sensible anymore. I actually had a reporter ask me to make a technology prediction 10 years out on the anniversary, the 10-year anniversary of the iPhone. And I said, do you think if you would have asked me 11 years ago what the impact of the iPhone, it didn't exist. We didn't know about it. And so the kinds of changes that are happening, the introduction of Docker, even if you don't use Docker in your ecosystem, the presence of technologies like that are going to influence how you think about your own architecture, which makes the job of the poor architect very difficult because central architects are responsible for the long-term asset value of the IT estate. And if you have no idea what's going to happen in the long term, how are you supposed to help nurture that value? So, what is evolutionary architecture? When you start talking about a new term like this, first you have to decide what to call it, and then you have to define it. And when I first heard Neil talk about this, he was calling it emergent architecture. And we had a very robust discussion about why that was a really bad name. Because emergent is not what we're trying to get at. I'm perfectly comfortable with the notion of emergent design because we can all pretty much agree what good code looks like and what bad code looks like. There is no such thing as the best architecture for everything. I worked for a time on a trading system, and now most people, when they hear the phrase trading system, think low latency, high throughput, got to really worry about performance. This system, this organization in its wildest dreams figured they might do 100, maybe 200 transactions a day. Not an hour, not a minute, not a second, a day. Completely different set of requirements. The kind of architecture we needed to worry about focused far more on the communication infrastructure. More traditional trading systems focus on very different things. So you just can't say what is a good architecture. It has to be specific to your industry. your system, your organization. I'll give you another example for that last one. I worked for a company and they wanted a distributed architecture. They were going from a particular kind of architecture, they wanted a centralized architecture. They'd had a wildly distributed architecture and wanted a centralized architecture. And so we presented a proposal for a centralized architecture. And the response was, but what happens if we lose Scotland? And I thought, how do you lose a country? But apparently what had happened is that at one point in their history, all communications between England and Scotland were down for days. And it was so drilled into the organizational memory of this organization that they could not, in fact, have a fully centralized architecture because they couldn't survive the loss of Scotland. Now, I'm sure none of you have ever heard that requirement before, but this was a real thing for them. So we ended up with this very strange centralized distributed hybrid to account for the fact that they couldn't, as an organization, have a centralized architecture because they would be vulnerable to losing Scotland. Now, another thing I want to say about the name. Many people have said, well, why don't you call it an agile architecture? Well, that doesn't really get to the heart of it. Many people have said, why don't you call it an adaptable architecture? And the problem with that word is it implies there's an adapter. If you're going to be adaptable, that probably means you have an adaptor that allows you to be adaptable. But you can't build an adapter unless you know where the change is coming from. And I don't know about you all, but my crystal ball has been broken for a couple of decades with how technology is changing. And so you can't really predict. But let's say you try. You try to predict where the change is going to come from, and you build this adapter. And then the change comes from over there. What do you have? You have more code, which means you have more bugs. It means it's harder to understand, and you may very well have made it harder to make the changes that you actually have to make. Why bother? Why not just try to leave your system in a state where you can make whatever change you have to make as easily as possible? Notice I didn't say easy. This is no more silver bullet than anything else is. Now you have to define it. There are a lot of very important words in this definition, but an evolutionary architecture supports guided incremental change across multiple dimensions. And I'm going to talk about the important keywords in here. And the first one is guided. As I alluded to earlier, the best architecture for my trading system is not like the best architecture for any other trading system. And so we have to have a way of specifying what constitutes our target architecture. What are the characteristics of the architecture that will give us success for our architecture? And that's something that you actually think about up front, based on the regulatory environment, based on what you believe your performance requirements are, and all of those sorts of things. What are the things that are important to you? And you characterize that. And Scott mentioned fitness functions. You characterize them by fitness functions. We use the word evolutionary as inspired by evolutionary computation. Back in when I was doing my postdoc at Los Alamos, I did a lot of work in genetic algorithms. And in various optimization techniques like genetic algorithms, you have something called a fitness function. And this is what constitutes good. And you use this fitness function to guide the creation of the solution to your problem. And it characterizes how close you are to the desired result. Well, we're just co-opting that into architectural fitness functions. And that characterizes how close are we to the architecture and the architecture characteristics that we find desirable. And we're going to decide these things in the early phases of the project, because this is how we guide our decision making through these fitness functions. Now, there's nothing new about the notion of a fitness function. If you've ever put into your build a cyclomatic complexity limit, you have implemented a fitness function. If you have ever put in a runtime CPU utilization monitor that would put off an alert if your CPU utilization went too high, you've implemented a fitness function. What we find useful is if you take all of these disparate things, operational requirements, performance requirements, security requirements, code cleanliness, and architectural structure requirements under the same name and under the same discipline, it allows you to have a conversation. So what do fitness functions look like? There are lots of different types of fitness functions. You've got some that look at a very narrow characteristic like cyclomatic complexity. You have some that you can put in your build and some that actually happen at runtime. Some are triggered mostly by a build, but not always, and some run continuously. Some are manual. We prefer automated, but there's nothing wrong with a manual fitness function. The single most important characteristic of a fitness function is that you and I will never disagree on whether it passes or not. So something like, binary yes or no respects the architectural dependency requirements. That's okay. Maintainable is not. Because you and I can disagree on how maintainable something is. But we can't disagree on whether or not it matches the architectural requirements. Some of them are time-based. For example, you might decide that you don't ever want to get too far behind on the upgrades of the frameworks that you're using. So when a new version of a framework comes out, it triggers first a warning. And let's say you've decided you're going to give yourself a 3-month window. After 3 months, if you still haven't upgraded the framework, it's going to break the build. So that's a temporal fitness function. Now, we very often get asked, are there domain-specific fitness functions? And I call those acceptance tests because these are architectural characteristics. Now, we could probably have a discussion on whether something like GDPR compliance would fit, because it doesn't matter what kind of system you're in. If you have people's data, you have to respect GDPR. So that is kind of both domain-specific and domain-agnostic. Here's some examples. One that people sometimes find surprising is the last one. The simian army is a whole suite of dynamic fitness functions that are holistic across the system. And the advantage of those fitness functions is that everything that is represented by those fitness functions are something that no one ever has to worry about anymore. I believe it's the doctor monkey that checks to make sure all of the endpoints are properly configured. And it will kick the endpoint out of the system if it's not properly configured. So you don't have to do that in a code review. Any of these things that are automated, you simply stop worrying about. And so then you can focus your attention from a governance perspective, and we'll talk more about governance later, on the difficult questions. Well, maybe you've run into a situation where some of these requirements are actually in conflict. And maybe you have to figure out, well, how am I going to get myself out of this situation if I cannot get the throughput I need without the caching that is actually against one of my particular requirements? You want to be able to focus on the things that require the brain as opposed to manually checking whether or not somebody has put in a cyclic dependency. The second reserved phrase in this definition is incremental change. And there are two kinds of change that we need to think about in this context. The first is application functionality. And there's a really neat framework that GitHub open sourced called Scientist. And it actually makes it pretty easy to even make dramatic change in your application in a safe manner. They used this when they had to swap out the git merge function for something else. And think about how fundamental merge is to GitHub. And they use the Scientist framework to do that. There are things like feature toggles. You can do some of these things through A/B testing, and all sorts of frameworks exist to allow you to swap functionality in and out. But the second is, how is it incremental from your ability to get this stuff into production? Now, fortunately, going back to what I said earlier about the charges that I was being professionally irresponsible, I will say that unless you've got a lot of the discipline that is required by continuous delivery, you really need to be cautious about these things. Because you can be making some pretty radical changes, and if you don't really know what your servers in production look like, you're taking a big risk in following evolutionary architectural principles. So we're going to talk more about this later, but I consider continuous delivery to be a foundational requirement for evolutionary architecture. And finally, across multiple dimensions. This is actually an old list of ILIDs from Wikipedia. It's actually missing observability of all things. We should probably update it because that's pretty important. But you cannot optimize for all of these simultaneously. Many of them are in fact mutually exclusive. And so instead, what you need to do, as I said before, decide what are the characteristics that are most critical to the success of your system. And you come up with a fitness function. And some of these you might completely ignore. Well, our contention is that evolvability needs to be added to this list. But just like any of the others, evolvability might not be a concern for you. I did some work with someone who was in the very early research phases of a product that he was trying to develop. And I had a really hard time explaining to the other thought workers on the project why he didn't want us to put in a unit testing harness, and he didn't want us to do all of these things because he was quite likely to just throw it all away and start over. If you're going to throw it all away, it doesn't have to be evolvable. And it was either the fifth or the sixth iteration where he said, now, this is the idea I'm going with. Now you can build your harnesses, you can do all of the things that you've been complaining about because this is the code base we're going with. But evolvability might not be applicable. And you've got to decide about that just like everything else. Now, people often say, well, the only truly evolvable architecture is a microservices architecture. In the purest sense, that might be true, in that you can maximize evolvability in a microservices architecture, but that doesn't mean that's what you want to do. The only truly non-evolvable architecture is the big ball of mud. You have to do an awful lot of work to be able to start making some of these changes if you're dealing with a big ball of mud. That's true whether it's ecosystem change or functional changes. You got to get yourself out of the big ball of mud first. As I said, microservices is probably the most evolvable, but that doesn't mean it's always worth it. And we'll talk a little bit about that more later. A structured monolith actually has many of the characteristics from a change perspective. If you are truly disciplined and keep a well-structured monolith, many of the changes that you want to make are not that much different from the changes you would make if you were actually in a microservices architecture. It takes more discipline, though, on the part of the delivery team. I did know one CTO once that decreed that no two microservices in his organization would use the same technology stack, because he was so worried about people copying things over from somewhere else to steal the functionality. Well, that doesn't work if they're all in a different stack. It's very easy, and it's so tempting. I've got to get this change out, and there's this thing over here, and it takes a lot of discipline to actually maintain a well-structured monolith. You don't get the deployment flexibility that you get with microservices, but a lot of the other change dimensions you can actually handle, which is actually different from a layered monolith. A layered monolith facilitates particular kinds of change. I need to swap out my database persistence layer. How often do we really do that? Most of the kinds of changes that we want to make are more functional in nature. And so they're going to cut across all the layers. And so having the well-structured monolith based on business domains, et cetera, is far superior from an evolvability perspective than a layered monolith. Okay, so let's talk about some of the principles. What makes something an evolvable architecture? And we're going to talk about how you develop things, how you test things, the dreaded people problems. I mean, you can't talk about architecture without mentioning Conway's Law, how we communicate. But the first is decision making. How do we make decisions? The last responsible moment means that you're going to wait as long as possible, as long as it's still responsible, before you make a decision. Now, the immediate question is, how do I know when that is? You look to your fitness functions. The things that you have prioritized as architectural characteristics are the ones you want to pay the most attention to. Now, there are still two possible scenarios here. One is it's going to have such an influence on how you develop code that you've got to make it early. Another possibility is there's still a lot of uncertainty about what the right decision might be, and so I want to delay so that I can learn more. Now, if both of those things are true, that's when you might want to build some kind of anti-corruption layer to make it as easy as possible to change your mind. But that's how you decide that last responsible moment. What is the impact going to be? And how much information do you have available to you? Because the longer you wait, the more you know. But the longer you wait, the more code you've committed that might be relying on an assumption that you will have to change. Architect and develop for evolvability. Architecting for evolvability is mostly around where do you draw the boundaries between your boxes. I'm not going to use the word component because that's, for some people, a reserved word, so I'll just call them boxes. That's one of the most critical decisions that you need to make. And one of the things that we have found is the closer those boxes correspond to something that your product owners and your business owners are thinking about, the more evolvable the architecture will be. Because when they're thinking about things, they're thinking about it in business terms. They don't care if it lives in system A or system B or system C. They're thinking about orders, or they're thinking about customers, or they're thinking about product. And so in their head, when they're conceiving what they want you to build, those are the building blocks. Well, if your boxes with nice, well-defined boundaries correspond to those building blocks that they have in their head, it's going to be a whole lot easier for you to move them around. And so figuring out where those boundaries are is one of the critical architectural decisions that you will make. Now, if it's a domain you're incredibly familiar with, this is easy. If you're doing a greenfield project in a new domain, it's probably hard. And so you are going to want to be able to move those boundaries in the initial phases, again, while you're trying to figure out what is the best configuration. Developing for evolvability simply means focus on readability, understandability, because you cannot change something you do not understand. It's just not possible. And so this is where code quality comes in. High quality code is much easier to read, much easier to understand, much easier to change. You don't necessarily care about the specific number that comes back so much as you care about the trend. If your quality numbers are bopping around like this and all of a sudden go like that, you want to know what just happened. But you're probably not going to pay a whole lot of attention to these fluctuations because they're not really important. That dive is important. It might indicate you've got, far more complex functionality that you're dealing with now, and you might want to think about doing it in a different way. We had this experience once actually with one of our clients where that dip corresponded to a new project manager that they had brought in from another division who banned pair programming, who banned unit testing, TDD, all of these things, and the quality took a dive. Gee, what a shock. But we were able to bring this in and say, look what just happened. Look at the timing. Maybe we need to fix this. Postel's law. This is keeping control over how the different parts of your systems interact with each other. And paraphrasing, it is be very generous in what you receive, asterisk. Don't open yourself up for security vulnerabilities. But if you're getting an address and all you really need is the postcode, don't validate the address lines. That way they can split it into one address line 1 and 2, or combine address line 2 and 1 into one address line, and it won't break your code. That doesn't mean there will never be breaking changes, but you can be as tolerant as possible. The other side of it is be very careful about what you send. Because depending on what you're doing, and by the way, just having a database is kind of sending information. You don't necessarily know who is relying on that information. We had a client once who did all of the things right in deciding what to do with a package. They changed all their internal business processes to match what the package wanted to do, instead of trying to customize the package. And they were so proud of themselves because now they could upgrade the package every time a new version came out. What they didn't know is that other parts of the business had actually created 87 reports that were critical to the business that connected directly to the database. And so before they could do this wonderful upgrade, they had to modify all of those 87 reports, which was an awful lot of work. They didn't know they were making this commitment of making information available. By following these, again, you make your system as tolerant as possible to changes. Okay, I admit I'm from Thoughtworks. That means we have to talk about testing. But one of the things that we have found is that if you think about how testable something is, you will tend to end up with a cleaner architecture and with a system that is easier to modify. It is very difficult, for example, to do automated testing when you have a lot of business logic on a pipe. You have a smart connection between two endpoints. Well, that's also not very evolvable because that business logic in there is making the assumption that system A is on that end of the pipe and system B is on that one. And so if you want to move that pipe to go somewhere else, you've got to change the logic on the pipe. That's why we advocate smart endpoints and dumb pipes, because you can move those pipes around as much as you want, and they're not making any assumptions. They're just saying, take what's coming out of A, give it to wherever the endpoint is. Another way to look at this, and this gets to understandability, If you can't come up with a nice, concise test name, if your test name looks like do this and this and this, and maybe this will happen, and then you probably need to rethink what that box is doing, because you clearly don't understand it. You ought to be able to come up with a reasonably concise, business-relevant description of what those tests are doing. And when you think about it from that context, you will end up with boxes that make conceptual sense, as opposed to boxes that are just kind of a mismatch. Conway's Law. My family has said at times that I went into computers because I don't like people, and that's not true. But there are an incredible number of problems that are really more people problems. I sometimes look very smart with our clients, show up there on the first day, meet with the VP of engineering in the afternoon, and I said, the integration here to here is broken. And he'll say to me, how do you know that? You haven't even looked at any code yet. I said, I saw the tech leads cross each other in the hall, and they were looking like that. If the people do not talk to each other, the systems will not successfully talk to each other. The communication patterns in your organization will influence your system. There's no way around it. It doesn't mean your people are bad. You just can't defeat Conway's Law. You can use it. We have something called the inverse Conway maneuver. This is the kind of system I want, therefore this is the organization I'm going to put in place and the communication patterns that I'm going to insist on, and then I will get the system I want. If you don't pay attention to how the organization corresponds to what you're trying to achieve, you're not going to get the benefits you're looking for. I had a discussion with a CTO, and she thought she had done everything right from the perspective of Conway's Law. But she forgot one thing. She had the cross-functional teams and all of that kind of stuff. But the individuals on those cross-functional teams, their primary reporting line was back into their practice. So their primary loyalty was to their craft, not to the project. And she was seeing all the dysfunction that resulted from that. Just switching the primary reporting line. You're not asking the people who are business analysts to not hang out with BAs anymore. But your primary reporting line, if it's going into the project, means all of the individuals on that team are aligned to the same objective. And it never occurred to her the importance of Conway's Law in that subtlety. Okay, that's all nice and lofty and abstract and all of that. How do you actually make it happen? I'm going to talk about 4 different techniques. Database refactoring, choreography, contract testing, and continuous delivery. There are lots of other ones I could put on this list, but these are the 4. And of those 4, this is the single most important one. I've been in agile software delivery for a long time. And I've heard the business analysts saying, oh, agile is fine for developers, but, I need to have my comprehensive, end-to-end, story put together before I can give it to them. And the testers, well, I can't test it until it's completely done because you're going to change it. The people I have always felt had the best argument against working in an agile way were the database administrators. Because as soon as you put something into production and you want to change the database, what do you have to do? Database migration. It sounds so simple. Copy the data here, over here. What could possibly go wrong? Anybody who's done it knows that all kinds of things can go wrong. One of my colleagues, Pramod Sadalgi, along with Scott Ambler, who is at that time at IBM, wrote the book called Refactoring Databases with the subtitle Evolutionary Database Design. And this is a recipe book for how to make data migrations as painless as possible. Now, let's face it, data does not age well. Well, there was that period of 3 months where we used this field for a completely different purpose until we could actually get the database changed. And so any records that were generated during that period of time have this weird value in this field. Those are the kinds of things that blow up data migrations. We've actually told Pramod we thought he should reissue the book, calling it Evolutionary Database Design, with the subtitle Refactoring Databases. But what they do is they look at all of the different atomic changes that you can make to a database and tell you how to do a particular migration for just that phase and how to make those changes composable. So as a result, rather than migrating the entire database all at once, you migrate the database for atomic change number 1, and then atomic change number 2, and atomic change number 3. And as it spits out all of those errors where you're uncovering the skeletons from 4 decades ago, you know it was just that one change that was responsible. Much like how we talk about having a tight loop when you're developing. If you've got a small change set, it's a whole lot easier to figure out what went wrong. And so rather than having 250,000 failed records, you have maybe 500 from one, and you can solve those problems knowing exactly what part of the migration affected it. This is probably the most important technique I will be talking about because it is a reality. Unless you are in this unusual organization that has perfectly clean data going back decades, you're going to want to know that. Choreography. This is one that you may not want to use. I put it in here because it is much easier to evolve a choreographed system than it is to evolve an orchestrated system. So let me set the stage here. An orchestra, there is a conductor, and he's standing at the front, and everybody's paying attention to what the conductor is doing. And if he happens to fall off the stage, eventually they're going to stop playing because nobody's telling them what to do. There are, in fact, some pieces that require 2 conductors because the different parts of the orchestra need to be following different directions, but that's beside the point. But that's orchestration. You have this person who is in control of everything that's happening. What about choreography? Think about a dance performance. The choreographer is not out there on the stage telling everybody where to go when they're doing the live performance. Each one of the individual participants knows what they're supposed to do. And importantly, they also have a sense on what to do if something goes wrong. So, if we are in the middle of the dance, and I am supposed to leap gracefully and have Scott catch me, and Scott trips, it's probably not a good idea for me to leap gracefully to fall on the stage. So I need to figure out, given the fact that Scott tripped, what I should do to allow the performance to proceed in the basis of failure. Rather than having a conductor tell us all what to do, we all need to figure out, Scott's got to figure out where he's going to go once he gets back on his feet. That's the difference between orchestration and choreography. Now, it's one thing when you have a human who is looking at the situation and saying, okay, what's the best way for me to get myself out of this so that the performance can proceed? It's another thing to write code for it, because there are failures in a choreographed system that just don't happen in orchestrated systems, because that's what the orchestrator is there for. You won't get yourself into the kinds of situations if you have an orchestrator than you can if you're doing a choreographed system. Much like microservices, there are failures that can happen in a microservices system that would never happen in a monolith. There's just no way for them to happen. And so what you have to decide is evolvability an important enough characteristic that you are going to introduce that level of complexity into your system. It might be. It might not be. With an orchestrated system, whenever you want to change one of those interactions, you have the potential of disrupting other parts of the system. That's not as true in a choreographed system, which is why the choreographed system is more evolvable. So this is not telling you should always use choreography, because that is not true. But if your ability to rapidly reconfigure your system is an important architectural characteristic, you might want to consider choreography. Contract testing. Probably the best enterprise architect I ever worked with had an amazing understanding of how all of the different systems in the organization fit together, and all of the places where it didn't make sense, but that's just how it was. And so she knew, yeah, it might look like that's the way you might want to make that change, but no, you can't because of this reason. She understood how that entire estate worked together. They were terrified she was going to win the lottery because no one else knew all of this stuff. Contract testing is first a way of documenting the assumptions that two boxes make of each other when they talk to each other. So Scott and I interact our boxes. And so I give Scott a test to say, this is the assumption that I'm making of you. And he does the same thing for me. And Venkat gives me his tests, and I give him mine. And then we ignore each other completely. I can make whatever changes in my box that I need to make, and I don't have to talk to them until Venkat's test breaks. And then I have to go talk to Venkat and say, I need to make this change. And we mutually agree how we're going to change things. It probably means that Venkat's going to have to change his box some too. We're still ignoring Scott because nothing is broken there. And then once our tests pass, we all go back to ignoring each other, which means even though we have lots of these boxes that depend on each other, we don't have to coordinate our efforts until we get that flag that says, it's time for a conversation, because you're no longer fulfilling your contract. So this is both a way to document all of those little secrets that enterprise architect understood, but also a way for teams to work as independently as possible. And I can evolve my box however I want, and it won't affect them. As I said, I think one of the foundational techniques, and this one is not optional, eventually you have to get to the place where you can guarantee what all of those different systems really look like in production. Are they all configured the same? I remember spending literally days poring over logs because occasionally 3 of the CPUs would just go off and spin. And it was always the same 3. It was never the other ones. And it turns out that they had a slightly different configuration than the other 5, and it was bumping up against a bug. When you're talking about making the scale of changes that we are with evolutionary architecture, you can't risk that. I've had many people say, I don't need to do continuous delivery because I don't want that random developer sitting in my delivery center to check in a piece of code and have it go directly to production. And my answer is always the same. Read the continuous delivery book cover to cover, and there is nothing, absolutely nothing in there that says that you can't have a human in the loop, that everything can't stop and wait for some person to hit a big green button to allow the thing to go to production. The point isn't for it to be able to flow all of the way in, it's that it can. That all of those steps are automated so that you can do it, which also means that if all of those steps are automated, you're not relying on some poor guy at 3 o'clock on a Sunday morning trying to actually be able to read the run book. I've been there. I don't care how good the run book is. Human beings do not like working at 3 o'clock in the morning. Machines don't care. And so the discipline of continuous delivery allows you to take more risks because you don't have to worry about the risk of deployment. To me, the single most important thing about continuous delivery is that you don't worry about getting yelled at by the CEO or CIO or whoever because you crashed all of the system with your deployment. You get to celebrate the features, not be grateful that this time it actually worked. Which brings me to experimentation. It's a whole lot easier to try lots of different experiments if it's easy to change the code. Part of why we ended up as an industry for so long with 6-month deployments or even 1-year deployments is because deployment was so hard. And so you had to be really confident that something was going to work. I often advise innovation centers of excellence, and they often ask me, how do you measure the success of an innovation organization? And the first thing most people come out with is, I want 100% of my ideas to make it into production. I said, that's wrong. Because if 100% make it into production, you're not taking enough risk. By definition, an experiment is something that you don't know how it's going to turn out. So you need to be able to safely introduce changes into your system. That's where the evolvability comes in. And you need to be able to safely roll those back and deploy them. And that's where continuous delivery comes in, so that you can do lots and lots of experiments. Because the more experiments you do, the more you are able to potentially run across some really great idea. So the combination of evolutionary architecture and continuous delivery gives you the platform for experimentation. And then you got to worry about the culture. Part of the reason people like 100% of the ideas making it into production is that means a manager somewhere doesn't have to decide, did that experiment not work out for a good reason, or was it just a really bad idea? Because some people do have really bad ideas, and you don't want to keep going with the person who has a long string of really bad ideas. But a well-crafted experiment will have a justification. These are the hypotheses that we are trying to validate, and this is why we think that there's a good chance these hypotheses are valid. And then if the experiment fails, you can do your postmortem and decide which hypothesis didn't actually work out, and you've learned something. This is a constructive failure. But it's a whole lot easier for a manager to say, successful experiment, good, failed experiment, bad. And in that kind of culture, you're not going to get the level of experimentation you actually need to be able to compete in today's world. Now, the dreaded G word, governance. Today's reality means that you can't feasibly have an architectural review board that meets once a month and decides whether or not you can proceed. That's just not feasible. And so what tools do we have from evolutionary architecture to help us with governance? And one of the things we have is fitness functions. Go back to what I said about the simian army. You simply don't have to worry about anything that is captured in a fitness function. As long as those things are in your build and sending alerts, you can't introduce new cyclic dependencies. It's not possible because the build will break. You don't have to check endpoints because they'll get tossed out. So we want to turn governance into, let's talk about all the things that aren't covered by fitness functions. And that takes away a lot of the things that are very often covered in architectural review boards. But a critical part of this is to shift the focus of the architectural requirements, particularly those that come from central architecture groups, to outcomes rather than implementations. Very often in the past, these architectural requirements would come in the form, use this framework, use this tool. This is how you use this framework and tool. That's specifying an implementation. The delivery teams will very often, if they're having trouble using that tool or framework in that way, in their situation, they're going to say, why in the world is this important? If instead, the requirements come down as, this is what we're trying to achieve. We are trying to make sure item potency is respected, or we're trying to make sure that there's guaranteed delivery, or we're trying to make sure ... What are the outcomes you're trying to achieve? They can put on an addendum and say, and our recommended approach for achieving this is that. But it gives the delivery teams the chance to bring in the context of what they're working on and decide, well, wait a minute, it's better to achieve that outcome in my situation if I do it this way. And so you're giving the delivery teams the information that they need to say, I would like an exception for this because why? Now, developers aren't any better at asking for outcomes as opposed to implementations. I've seen this happen a lot on many different delivery teams as well. We are hampered by the fact that we actually know what it takes to implement some of these things. But governance needs to shift to what are the outcomes we are trying to achieve as opposed to this is what you are going to do. And you can just guess what the outcome is. Okay. Many of these things probably sound all fine and good if you're lucky enough to be in a green field. But I suspect the vast majority of you live in a brown field where you've got legacy code and lots of different systems and lots of different states of repair or disrepair. What do you do then? How do you make something evolvable when you're dealing with a system like this? Well, you start at the same place. What are the architectural characteristics you would like your system to display? What are the things that really worry you about the system? You might check your GitHub commits or your bug database. One of my personal favorites is to go talk to the customer support people and the operations support people if they're different from the team and say, when do you get nervous when the delivery team tells you that they're going to be changing a particular thing, and let's go look at that thing and try to figure out why it is that it makes everybody so nervous when you're fiddling with it. And then select the dimension you're most worried about. I didn't say select the dimension you think is most vulnerable to change. I said select the dimension you're most worried about. Perhaps, though, you've heard that the business strategy for your organization of the next 3 years is to grow by merger and acquisition. I'd probably suggest looking at your integration. But pick something and start improving on that, just that dimension. Don't break builds if you're not meeting those characteristics. But now you've got a record of how you might be improving. And don't worry about the specific numbers. Monitor the trends. One of the common conversations I have with our clients is I'm brought in to convince the VP of engineering or whoever to give the teams the chance, give us 6 weeks to resolve technical debt. Most common question I get is, how do I know you're not going to be back here in 6 months' time asking for another 6 weeks? I said, one of the things we're going to do is we're going to put in all of these fitness functions that are going to monitor all of these things. And so it won't happen again. Or if we think it needs to make a deadline for whatever reason, we'll be able to tell you. You want to focus where it matters. I used to be a computer science professor, and I would love if there was never any ugly code, any bad code, any spaghetti code, any big ball of muds anywhere on the planet. I realize that is unrealistic. There might be one part of your application estate that is absolutely messy and horrible and terrible, but it hasn't changed in 5 years. Don't touch it. Don't waste your time there. Maybe by the time you have to do anything with it, you can actually throw it away. Focus your efforts other places. This last point is the important one. Monitor the trends. And once you get comfortable with that thing you used to be really worried about, pick another dimension and start all over again. It's going to take a while, particularly if you're starting with a big ball of mud, or particularly if you're starting with a technology stack that's highly coupled. There are all kinds of reasons this is going to take a while, but it is possible. And as you start to introduce more of these disciplines, it's going to make that system easier. Not easy, easier. And finally, this whole thing was talking about how we don't know what is going to change when, but everything is changing frequently. You can't just at the beginning of your system decide what your architectural characteristics should be. You need to revisit them because new things might appear in the ecosystem. Maybe you've done a merger and all of a sudden your user base has tripled. And so now your performance requirements are way out of whack. There are all kinds of things that might have happened. So you need to evolve your fitness functions. But the way I want you to think about this is the following. It used to be we had these massive architecture diagrams on the wall with all the boxes and all the roadmap stuff and everything. And that was the target architecture. Our target architecture now is represented by the composition of all the fitness functions. That's all it is. That composition encapsulates all of the things that you hope your system will respect about the architectural outcomes. This is the performance you want. This is the code quality you want. This is the ... that you want. That is your target architecture, and it allows you to change your system confident in the fact that you're not going to break any of the assumptions that you're making, because it's never going to get into production without you knowing about that. So evolve your fitness functions, or you're not doing evolutionary architecture. Thank you very much.